Hey there. In this video, we're going to take a look at some examples of the observer design pattern in action, along with extending a little bit of the code we wrote in our previous video. So without further ado, we're going to start off by continuing the previous set of exercises, namely the ones that we had our game entity. And so for this, I'm going to go straight back to our code from polymorphism. Exercise 4. Let's clean up the directory first. Just do a quick make clean. And I want to grab everything that's in here. Copy it all. And let's go over to our observer. Exercise 5. Okay, so what are we doing with this exercise? We are going to implement some virtual methods for interaction between game entities, such as collide with game entity. It's going to behave differently depending on the types of game entities that are interacting. So we have a few changes to make. So in order to make game entities interact with each other, first of all, I should say that game entities can do this. So I need a virtual method called collide with. We'll just make it a void. And I'll need to implement this in all of my different kinds of game entities. And so probably I'll make this a pure virtual function. In order to know what entity I'm colliding with, I need to be able to get the type of it. So let's do a void. I guess we'll do another virtual. This one will actually be a string get type. And then finally, I want to be able to grab the name of a game entity. So let's just make a string get name. And this one is just going to return our name. And the reason I'm doing this is because when I collide with something, I want to know the name of the thing I collided with. Okay, so this is the updates to my gameentity.h. Now let's go and implement these functions. First, I need to actually say that these are part of the character and item classes. So let's go do that first. So here, I need to have get type and collide with, and the same thing for my character. And now in my CPP files, character and item, I need to implement these things. So let's start with character. We need to mention that these are character functions. Character. Let's do get type first, because this one's really easy. All I have to do is return the word character. I just want to know that it's a character. Now, when I collide with something, I want to get the type of it. If the type of it is character, then I know my character has applied with another character. I can do something like say, this thing collided with entity arrow get name. This is where our get name function comes in. Let's do actually that. Otherwise, I must have collided with an item. So I'll say name hit an item. Okay. And I'll do similar things for our item here. But here, I have an item. And if I collide with a character, I'll say, how about this output entity arrow name picked me up. And here crash into another item. Actually, how about we'll do picked name up. There we go. Just so we have some slightly different functions going on here. Okay, now what we'll do is we'll make our things collide with each other. In our main function, let's comment out some of this. We don't need this here. So we got our we got three entities here. We have Pac-Man and two kinds of power pellets. So we'll do c.collide with our item 1, and then we'll have it collide with itself, and then we'll have our item collide with Pac-Man, and then our item collide with the other item. And let's see what happens. Okay. Make run. Oh, I got some problems here. Character has not been declared in item.cpp. Right, because I forgot to correct, this should say item. Okay, let's, and let's see. Name was not declared in this scope. Does my item not have a name? Oh, it's because it's the same error. It's just the same error. Okay, so there we go. Pac-Man hits an item. Pac-Man collides with Pac-Man. Pac-Man picks up Power Pellet. And we see basically the 4 different messages that we wrote from the different kinds of collisions. So this is kind of, again, another form of polymorphism, where basically we have one function, the one function being called collide with, and it behaves in different ways based on what sorts of things are involved in the collision. Okay, so that was our first little just sort of extension of polymorphism from before, but let's delve into the observer pattern. So the observer pattern is going to require us to make 2 abstract classes, one called observer and one called subject. Our observer is going to need to be attached to our subject, so our subject is going to have a vector of observers. And the observers are all going to have a update method that does something when they receive an update. And our subject is going to have a method called notify, which will notify all observers. Later we'll get the implementation stuff specifically from it, but first let's get these abstract classes going. So make clean, so clear away some of the extra stuff here. Copy all this into a new folder, example 6. Okay. So we need a new observer.h. So this is a class called observer. I believe, do I need to include this more than once? I don't think I actually do. I think I'll need to include it one time. Now, what is a observer going to do? It is simply going to have a virtual void update method, which is a pure virtual function. And so what this does depends on what kind of observer you're working with. You can imagine in this video game scenario, your observer could be your health bar, it could be your inventory, anything that relies on something else to change over time that might have an update method can be an observer. So I have my observer. I also want to have my subject. My subject's going to be a little more involved because my subject is going to have some stuff. It is going to have a, sorry, this should be protected. No, this one is going to, oh, actually, yes, we will need a pragma once here because I am going to, oops, I am going to include this a couple times. Pragma once. My subject is going to include observer.h because, and also vector, because I want to have a vector of observer pointers called observers. So these are all the people observing the subject. And the subject is going to have 2 public methods. One is called add observer, given a observer pointer, and it will simply say observers.pushback. Sorry, oh. And the second method that we're going to have here is called notify. Now, typically notify will take a oh, sorry, and this is a standard vector. Typically, notify will take some kind of message. So we'll say here, actually, this should be abstract as well. This is a virtual void notify given a string message equals 0. And we will implement how we notify our observers in the concrete version of our subject class. Okay, so let's now go to our, first let's make a kind of observer. So our kind of observer is going to be a game observer. sorry, these should be CPPs because I'm not going to have headers. So this is CPP, this is CPP, this is CPP as well. I'm not making headers for these. They're very short. So Game Observer is a class that will print messages when it receives notifications from a character, and a character is going to be a kind of subject. And the character, so perhaps let's do character first, actually. So over here, we said that a character is a game entity, but after we include subject.cpp, we're actually going to say that character is both a game entity and a subject. And what this means is now my character needs to implement this notify function, void notify. I think I need IOStream over here in order to use a string. So given a message, I will need to notify my observers. So here is my notify method. And what this will do is we'll say for each observer pointer O in, what's the name of my vector? Observers. arrow update, and the message we will send is the message. So actually that means my my update here should also be taking a string. There are different options of how you set up your update. Sometimes the message is appropriate. Sometimes you want to send data of other kinds. It's sort of up to what kind of observers you want to work with. For here, we'll just send with sending some messages around. But you can imagine sometimes the updates will look a little bit differently. Perhaps you have like a giant, block of all the information that you're sending for perhaps about someone's inventory, and then maybe you need to send a whole list of all the items that are there. But for now, we're just going to stick with sending some messages. So when our character notifies all its observers, it updates them all with whatever the message is. And when do we call this? Well, we said we were going to call it in update. So what we'll do is when we update, instead of putting new appearance of thing as thing, how about we do a notify, and the message is this message. I think we can just put some pluses in. Should be able to concatenate all of these together to form a message. So if we do this correctly, this should now notify all observers when our updates have happened to say that the appearance of this thing has changed to something new. Now, we need some observers to actually be watching our subjects. So our game observers are going to be pretty simple. They are going to include our observer.cpp and a game observer is a kind of observer. In order to be an observer, we need to implement this update method. And we're just going to implement it really simply, which is we're just going to print it. Maybe we'll at least write in a message that says, using namespace, let's see. We do game observer received a message, output message, end of message. To get some more verbosity and seeing what's happening here. Okay, now last but not least, I want to make some observers in my main, which means I will need to include game observer.cpp We can get rid of our collisions for now. Let's actually bring this back. This is where we had our original game loop. But what we will do is we will set some observers on Pac-Man. So game observer GO1, GO2, GO3. We can imagine maybe this is different, bars in the screen and stuff like that. And now I have to add all these. C dot, what's the name of our method? Add observer GO1, 2, and 3. Okay, let's see what happens. Can I build this, or did I crash it? Make clean everything. Make and go. Oh, what did I mess up? It's not observer.h anymore. It's observer.cpp. I missed a parenthesis in character CPP under notify. Right here. Wait, no, that's not it. Here. Okay, and now, as we update our Pac-Man, so our Pac-Man originally looked like this little mouth, and then we added an O, and now over time what you'll see is that as I constantly update, and I update the new appearance of Pac-Man, all of my game observers receive these new messages that say, hey, look, Pac-Man looks different now. And maybe that matters if, for instance, my graphics engine requires to have a new model that's going to render, and these sorts of connections between the different objects that are there. But we now have this observer pattern here. What did we have to do? We needed to make our abstract observer class. This could matter if, for instance, I had something besides game observer. Game observer here, very boring. It just prints out some messages, but maybe there's different kinds of things that are observing. Health bars and, game stats and inventories, even graphics and stuff like that. Maybe observers are different kinds. The subject is the actual thing that we're looking at here. Our subject abstract class has a notify method that is needed to be called anytime something changes, as well as a method to add new observers to the object. And our character is a subject. Note here that we are doing what's called multiple inheritance. We have a character that is not only a game entity, it is also a subject, which means it has all of the properties of both and all the requirements of both. It needs to implement all the virtual functions from each of them. In my main, all I'm going to do is I'm going to make some game observers, attach them to my character, and then see what happens. And because my game entities, my characters are being updated, we get these messages being sent to our game observers over and over and over. Okay, so this is our observer pattern, and let's see what last things we can add to it. Okay, so now that we have our observer class, let's make a new abstract class called state. Something like a state class might be very appropriate if you have different kinds of situations that a character or another object might be in. And these can refer to things like, I am in the idle state, I'm not moving. I am in the attack state, I am attacking. I'm in the move state, I am moving. And these will each implement the virtual methods enter, execute, and exit in different ways. So you can imagine entering the move state might be my character who was standing still now begins to move, and so on. So let's implement all of this. I guess first thing is I should clean up my folder and move all this into example 7. Example 7. Okay, paste. So here I am going to make a new state.cpp. Now here I'm just going to put everything in here. It's a little sloppy, I know, but I think just going to put all of my state stuff in a single file just for the sake of keeping my number of files from getting a little out of control. Probably when you start having this many files, it might be good to actually split them into separate folders. Maybe I want to have all my game entities in one spot. I want to have my state in another spot, something like that. But for now, I'm just going to try to put as few more files in here as I can get away with. So I need to make a class called state. State's going to need to have some pure virtual functions. I believe they are execute, enter, and exit. So virtual void enter equals 0. Execute and exit. So these are my pure virtual functions. And then my classes will be things like idle state, which is a kind of state, and it's going to implement these methods. Let's do move state first. So I think move state, they said, when you execute the move state, it should print makes a move. So let's do that. When I execute the move state, output makes a move. And we'll do something similar for enter and exit as well. So when we enter the move state, we will say has begun moving, and exit means stops moving. And we'll do this again for idle state and attack state. When we enter the idle state, we will say has begun standing still. Here is stand still. Here stops standing still. The attack state has begun attacking, makes an attack, stops attacking. And you can see here they all kind of use the same interface here, which is they're all kinds of states. They all can be entered, executed, and exited. And now, okay, so now I have all of this stuff. Let's make sure that this works, and all I'm going to do here is I'm just going to g++-c state.cpp. Oh, am I in the wrong folder? I am in the wrong folder. Try that again. g++-c state.cpp. Okay, so it compiles okay. So for now, everything seems like it should be all right before we move on to our last little exercise. So now that I have my states, we want to use them. So we're going to modify our game entity class to use the state classes and modify our loop to enable these entities to change their states. So in my game entity class, we're going to give it a state, which means I need to include state. I'm going to include state, I think. Actually, will I include state? No, I think state's going to be something that's specific to game entities. Nobody else needs to know what attacking and idling and moving and so on are. Just our game entity is going to deal with that. Now, we need to have a state. So this is going to be called state. And initially, state equals a new idle state. And so what this does is it makes sure that when we create our new game entities, they initially are not moving in any way. Now, perhaps we don't care about the state of our items. We'll just leave that as it is. But maybe our character we care a bit about that for. Over here, when we render our character, how about when we update our character? We'll say there's a new appearance of this. And how about here is where we'll alternate states, just to sort of demonstrate how this is working. So if, I guess you have to think a second. How do I want to know which state I am in? Probably to do that, I need to have a function in here to tell me which state I'm in. So let's make that get state. And this will return a string. So here I will return move. Here I'll return idle, and here below I'll return attack. And my goal is basically to have a function that when I call it, I can know, am I moving, attacking, or standing still? So now that I have get state, I can say state arrow get state is move, else if it's idle, else. Now I have my three different situations I can be in, and how about we just change them? So how about we say state arrow exit. We're exiting what state we were exiting the moving state. We will delete the state because we don't need to be moving it around anymore. That part of our character is gone. We will have our state become a new idle state, which I think means, do I include state here? Where did I include state? Oh yeah, it's included in as part of game entity. Okay, so we know that that exists. Not a problem. Okay, so we know that states exist. So we know that an idle state is a thing. State arrow enter. Actually, we should state arrow execute before we do any of this changing. So we'll execute whatever state we're in. Then we will exit it, we'll delete the state, and then we'll change into a new one. Make this code a little bit shorter just by reducing the amount of duplicated code here. So no matter what, we're going to run the state we're in, we're going to leave it, drop the state completely, get a new state, which will be idle, attack, or move, and then enter that new state. Okay, let's see what happens when we put this all together. I made the classic blunder that I always do, which is I seem to have put all of the code that I just wrote into exercise 7. I think that's okay. We're just going to rename this as 7, 8, just to show it all in action. Oops. Make clean, make run. I got a seg fault. That's not a good thing. I think the issue here is that I have deleted something. Yeah, there's some issues for sure with the states here. I think maybe in the state is a new idle state. Yeah. When I create my game entity. See, when I put standing still, it didn't load the name, which is a bad sign. Oh, I guess I was supposed to write the name of it and then standing still, so it was actually doing okay. Let me go back to my character. Before I do execute, I should do cout name and then execute. Cout name exit, cout name enter. Delete the state. I try to make a new one and I wasn't happy about that. Deleted the state. Oh, right, duh. I have to get what the state is before I can delete it. That would be the problem. Okay, there we go. How about, actually, the cleaner way to do this is let's get the state first. State name equals state arrow get state. Then I can delete it, and then I can just replace this with this. Again, we want to reduce the number of lines of code if possible. Okay, so my problem was that I had deleted the state and then tried to call the getState method, which you can't do, obviously. So instead, I'm going to get the state name first, then delete it, and then check to see where we're at. Okay, trying again. Make clean it up, and then let's go. Okay, so Pac-Man stands still, stops standing still, begins attacking. Makes an attack, stops attacking, begins moving. Makes a move, stops moving, begins standing still. And you can see it goes through the same little cycle of switching between all the states here. And this can be really helpful because now it means we can add different properties to these states. Maybe when I'm in the, check to see, am I in the moving state? If I'm in the moving state, then render my graphics of me moving. If I am idling, don't do that. If I'm attacking, run the combat math or whatever happens when you're attacking. So now we have this whole little system here that represents our little game. And obviously we don't have a full-on game or anything here, but these are the pieces that need to be present in order for this game to exist. So thanks for watching the video. Hope you found it useful, and I will see you in the next one.